Okay, here's what we got. 2002 Buick with a 3800. Problem with this one was poor acceleration at times. Out on the freeway, they couldn't accelerate. Other times it'd run just fine. The only code that popped up was a low voltage code for the upstream O2. But O2 is not the problem. That actually set low voltage will happen on an O2 sensor when the engine's running lean, which some of the time this thing wouldn't. It'd run great. Actually, most of the time this thing would run great. But I want to show you a way that we can identify what's wrong through some scope testing. Now, the fuel pump is the failed problem, but I'm going to show you how we figured this out. So I got the Pico up here with my scope. What I've done here is taken an amp clamp and I put a fuse buddy in place of the fuel pump fuse. So all the current that's going through that fuel pump right now is going through this loop, which is measured by the clamp, which is going to be shown on the Pico here. So as this thing's running, and it's actually running halfway decent right now, you know, if I really loaded this engine up, I'm sure I'd have some trouble accelerating, but like I said, other times it was just fine. And actually when I captured this at first, it didn't have the dropout, and it slowly got worse and worse as it ran. But I'm going to pause the screen here. And we're going to zoom in on a section of this. And actually, I'm going to shut the car off now that I have the capture, just so you can hear me a little better. Okay. So I'm going to zoom in on this so you can see what we're talking about. Now, again, this is amperage, so you know we're pulling, I'd say somewhere, if you average that out, maybe around 6 amps or a little bit less. And you can see that we have these up and down spikes, and then we have this one repeatable dropout where it goes to 0, which means at that point right here, that pump's not drawing any amperage. And a normal pump waveform should not look like this. So let's zoom in just on one section here. So what we're really looking at is from this point here to this point here, that's one rotation of the fuel pump. So the fuel pump is basically in a cylinder form. It's the armature, and it just spins around, and it has a little impeller on the bottom which pressurizes the fuel into the fuel system. Now what should happen is we should see a spike in amperage and then a drop, but it should not drop all the way down to 0. What that's representing is a bad commutator section in the fuel pump. So I made a little drawing just to explain what I mean here. So if you look at the bottom of the pump, most fuel pumps are split up into 8 commutator sections. There's ones that are more 10, 12, 16, depending on the make, but a lot of domestic vehicles are split into 8 sections. So again, this rotates. Well, what happens is we've got our commutator sections here, and we have brushes on the side of the motor. They actually make contact here on the bottom side, but this is just a drawing to represent. So when these two sections lined up, we're sending current through the motor, generates a magnetic field, and there's permanent magnets on either side of the motor, rotates the next commutator section. But when we see this dropout here, where it drops all the way down to no amperage, there is no amperage here, that's representing a bad section. Now it could just be one of these actually, but I'm just showing you across here. For one of those sections, we are not getting current flow through that motor. Now this can be intermittent, because in this case it's just a bad contact inside the motor, but then that was the case with this one. Now we do want to see a little bit of up and down on this amperage waveform, okay? So we want to see some ups and downs, some ups and downs, some ups and down, and that is just moving between the commutator sections as we rotate inside the pump. But what's nice about this test, and that's really what this video is about, is we can catch this, you know, before the pump's completely failed. I mean, obviously it's running, and you could do a pressure measurement. I think on this particular application, you'd have to do a pressure measurement under load, or you'd have to do a fuel pump volume measurement to be able to determine this. This is a nice, quick, easy way. It took me, you know, 30 seconds to set this up under the hood. Didn't even have to get my hands dirty, and I can call a fuel pump on this, no question. So that's what we're going to do. We're going to replace the pump, and maybe I'll have an after capture for you here. Okay, for the second part of the video, we replaced that fuel pump and it took care of the problem. The amperage waveform looked way better. I thought I saved it on my computer, I didn't. But anyways, this is the pump that we took out of the car, and I actually cut the bottom off of it. So just a permanent magnet style motor. You see the two magnets on here, and you see down in there are the two brushes. I will focus on one of them. You can see that they are pretty worn out. The one on the top there looks pretty worn out. And those guys, they just operate off of spring pressure, so I'm pushing it in and out. And what the two brushes do is they ride up against this these commutator sections here. Okay, so we send current through the winding from one side to the other, build up a magnetic field, and that's going to, repel against those permanent magnets that are in the housing there. That's just how any electric motor works. But the problem with this one, so if you take a look here, you see how worn down these sections are. That copper section should come all the way up to the top here. But if you think about how long this fuel pump's probably been in there, if it's, original pump, I don't know whether it is or not, that's 200 some thousand miles that this thing's been spinning, and it wear down just like anything else. Now, what was the bad section? What was the one that was really dropping out? Hard to say. It doesn't really matter. That test is still pretty effective, but pretty clear cut. And when you have a worn out fuel pump, this is generally what's happening. Sometimes it'll completely stop. You can hit the tank with a hammer, just sort of rotates. It's enough to rotate this to a different commutator section, and then it'll start and run. But again, you look at that amperage waveform, even if the pump's working enough to run the vehicle, it's making some pressure, you can pick out a worn pump like this with this amperage test. So what I wanted to show you here, this is not off of the fixed car, but it's a very similar waveform. It's an amperage waveform taken off of a known good fuel pump. Now you can see the up and down spikes, but you don't see a complete drop down to zero, because each one of those up and down spikes is one of these commutator sections as this rotates around. So it hits the gap and the current drops, and then we get to the part that actually conducts and the current ramps back up. But on our failed pump, one of those sections was no current, high resistance, dropping all the way down, which slows that pump down. And if it gets stuck on that section of the pump, it's obviously, it's not going to move. It's not going to spin because there's no current going through it. But again, you don't really need to take these apart to see what happened to them. I did it just to show in this video. But this amperage test, it works on any electric motor too. You can do this on a cooling fan. You can do this on a blower motor, any electric DC brush style motor. This is going to work for and be pretty effective in determining whether you have a motor that's failing. And with a fuel pump, that's really helpful because it's inside the tank. You can also look at this. You can calculate RPM using this. Sometimes you use that to pick out an empty gas tank. You can see the overall amperage level as well. It's going to depend on the pump that you have, but a lot of them are close, somewhere in that 7 to 6 amperage range. You don't want to see it a lot higher or a lot lower. That could indicate a number of issues. But again, just the visuals on this one was enough. Super easy test to do.